In chapter 2, we're going to be learning a lot of definitions about lines, planes, and space. So a whole lot of definitions in chapter 2. And we're starting off with subsets of lines, uh, and then we'll move on to subsets of planes and then subsets of space. So let's jump into this and start this. The first term is called a half line. Not a very well-known term in geometry, but a half line is the set of all points on a line. So there are a bunch of points on a line on a given side of a given point of the line. And so for a half line, what we do is we choose a point and we want all points on on one side of that line. It doesn't matter. We could choose this half line, so all the points to the right of J, or we could choose half line, all the points to the left. Now, the end point here is not included. So half line JK is all the points on the same side of J as K, so everything to the right in this case, but does not include J. Pretty important since it's in all caps. We denote half line JK as this. We see an open circle with an arrow pointing to the right. We always use an open circle with an arrow pointing to the right. If we want to choose points to the left, we have to change our starting point or just or change the ending point depending on what we're talking about. So this is a lot like inequalities. When we graphed an inequality on a number line, we would have an open circle. We use open circles when it did not include the endpoint, and same thing here, it does not include the endpoint. Give another name for half line, for the same half line. So what we can do here, we can give another name for that, and we could call this half line. So we're going to start with this symbol here, and we start with the same starting point J, and then we can just pick M. We could use M here, or we could do half line JN. They represent the same half line as JK because that second point just really tells you which side of J you want to be on. I'm going to write a couple other things up here. There's other half lines here. We have half line MN. I'm not going to write all of them, but MN is another half line here, just so you get the idea. That's our starting point is M, and then we want all points on the same side of M as N, so we want everything over here. We also could say half line NK. And so we write it this way. Half line NK means we start at N. The first one's always our starting point, and the second one always tells us, or it gives us a direction, so we want to go towards K. So that half line NK would actually be that half line, starting at N and then going to the left. Is half line JK the same as half line KJ? Well, the answer to that, we could look up here. Half line JK is the one starting at J and going this direction. Half line KJ is starting at K and going in this direction. So they are not the same half line. So the answer there would be no. We have this first postulate here in this chapter, the line separation postulate. It says every point divides any line through that point. So there's points all over, and there's lines that go through that point. It's going to divide any line that goes through the point into 3 disjoint sets, and those 3 sets are, the first one is the point itself, and then the 2 half lines. One going to one side of that point and the other to the other side, maybe right and left, maybe above the point or below the point. So here we have a line. A demonstration or an example of this would be point M divides this line into 3 disjoint sets. The point itself, so point M, and then so the point M, and then the 2 half lines, the one that goes this direction, so half line MJ, and then the other half line that goes this direction. So those are 3 disjoint sets, and if you take the union of those 3 disjoint sets, it gives us the whole line. And so that is the line separation postulate. We could say this in another way. We could say, we could do a different one. So we could say point K separates it into K, half line Kj, which is everything to the left of K, and then half line Jk, which is everything to the right of K. And so that's another example. And then array. Array is the union, so we talked about, when we talked about sets, we talked about union, of a half line and its origin. And so we're taking a union, so we want all of the half line, and then we want to include the origin. So array does include the endpoint. Array extends infinitely in one direction. So here's an example of array. It starts at x and then goes through y and keeps going on infinitely. We would call this array xy, and we can name it like this. It looks a lot like a half line, except the half line had this circled open circle here. For array, you don't put a closed circle, you just put the arrow. Also, the origin or endpoint of the array always is named first. So even if we're going to the left, if we had an array that looked like this, going this direction, and we had A and B here, we would call this ray BA, because B is the origin. So even though it's pointing to the left, we denote it as the starting point first.